Hi, and this is Chapter 3, Topic 4 video for direct variation. Direct variation is described by an equation of the form y is equal to k times x. You will need to know that equation, and we are going to practice with it a lot. And k can never equal 0. Y equals kx illustrates a constant rate of change, and k is the constant of variation, also called the constant of proportionality. So in example 1, it says name the constant of variation. We're given this equation that I just highlighted in green, y equals negative 2x. So my k value is equal to negative 2. Now let's find the slope of the line. I'm going to pick this point, and it's rise over run. I go down 2, so negative 2, and over 1, which is equal to negative 2. Notice that those values are the same. Let's see if that's the same case for the rest of them. Name the constant of variation. Again, highlighted in green, y equals kx. K must be equal to 3/2. And then if we take a look at the slope, choosing 2 points, we have 1 point here, 1 point here. My rise, 1, 2, 3, is positive 3, and I am running 1, 2. So those values, again, are the same. So the slope equals the constant of variation. And then what point do both of these graphs cross? Well, that's the origin, which is 0, 0. And every direct variation equation will cross that point. When we graph direct variation equations, it's good to remember that every single direct variation equation has a point at 0, 0. So let's go ahead and before we even look at the equation, to plot a point at 0, 0. Then if we say that k is equal to 3 here, our slope is also equal to 3. So from there, we can rise 3, run 1. So we have 2 points which make a line. Let's try the next one. We know that we have a point at 0, 0 because it's direct variation. And our slope is the same as our k, which is negative 3/4. So from there, we're going to go down 3 and over 4. Plot the point. I'm going to clean it up a little bit. And go ahead and connect those 2 points with a line. Why don't you go ahead and do the U-tries, and we'll meet for the notes on the next page. Now we're going to look at writing and solving direct variation equations, so not requiring a graph. This tells us suppose y varies directly as x and y equals 30 when x equals 5. So we're always going to use our formula y equals kx. So what we're going to do now is use the first set of information given. So it says y is equal to 30 when x is equal to 5. So we can substitute those values in. It says y is equal to 30 and x is equal to 5. We need to solve for k in order to write the formula. So 5 is being multiplied by k, so to undo it, we divide both sides by 5. 30 divided by 5 is 6, and k times 5 divided by 5 is just k. So when we write the actual equation, the direct variation equation, we use y equals our k value, which is 6, and x. That way we can use that equation given any x or any y. So let's look at part 2 of this question. Use the direct variation equation to find x when y is equal to 18. So we're going to use y is equal to 6x, but then we're given the information that y is equal to 18. So let's go ahead and plug that in. 18 is equal to y, and we know 6 times x. This is nice. We can solve this equation by dividing both sides by 6. And get that? We get x is equal to 3. Go ahead and work on the U-tries, and we'll meet at the next page for the rest of the notes. One of the most common applications of direct variation is d equals r times t, which means the distance is equal to rate times time. So if we look at this statement, it tells us that a family drove their car 225 miles in 5 hours. So we're going to write a direct variation equation to find the distance traveled for any number of hours. So we know that they drove their car 225 miles. We don't know our constant of variation, but we do know it took 5 hours to do this. Now, because k is being multiplied by 5, to undo it, we're going to divide both sides by 5, and we get 45 is equal to k. So now we can write our direct variation equation using that k value. So we have y is equal to 45x. So that means that their distance is going to be 45 times their number of hours. And I actually need to use, instead of x and y, I need to use distance and time, because that's what the formula says. So it means 45 is our rate, so that means we're at 45 miles per hour. All right, go ahead and do the U-try on this page, and that will conclude your homework tonight.